Welcome to Microtrac's free webinar, How to Meet ASTM Standards for Roofing Shingle Mineral Granules. If you have any questions during the presentation, please type them into the question box in the control panel and we'll be happy to answer your questions at the end of the presentation. A recorded version of this webinar will be available on our website, microtrac.com. So your speaker today is Terry Stauffer. Terry works closely with Microtrac as a particle characterization specialist. He has over 40 years of experience in the industry. So in today's presentation, we'll go over the composite roofing shingles and the damage and wear, the requirements for mineral granule coatings as outlined in ASTM standards, and finally we'll go over 3D dynamic image analysis and how it can help improve your quality control efforts. At the end of the presentation, we'll be happy to answer your questions. So without further ado, I'll turn it over to Terry.
Thanks, Claudia, and welcome to our webinar. Composite shingles are composed of mineral granules covering a layer of asphalt, which has been applied to a fiberglass or cellulose mat. The mineral granules provide protection from damage, wear, and drying out of the bottom layers. Granule loss from damage or wear comes from ultraviolet sunlight, drying of the asphalt, shingle blistering from heat, mechanical damage, hail, normal aging, and defective roofing. The mineral granules must be opaque to prevent the UV sun damage, and their size distribution must be reported in the size intervals published in ASTM Standard D451. Here on the right are the ASTM standard size interval requirements for granules. 10 different size intervals from 3.35 millimeters down to 150 microns. The final product batch still needs to be certified by sieve analysis before shipment, but size can be quickly controlled during processing as often as every 15 minutes using Microtrac's image analyzer and taking immediate control action. Sieve analysis for particle size process control has been replaced by newer automated analysis methods in most applications for a number of good reasons. It eliminates weighing or transcription errors by the operator. It eliminates error from worn sieves, and it greatly decreases the manpower time and cost. It increases accuracy, precision, and reproducibility. Dynamic image analysis as performed by Microtrac's PartAn 3D model is the only automated technology that can handle the large size range interval required by roofing shingle granules. This technology has the added advantage of measuring an opacity parameter called transparency and a shape parameter, rectangularity, which indicates the coverage efficiency of granules on the asphalt layer. This figure illustrates how the 3D mode works. The system tracks and photographs the tumbling, rotating orientations of each particle, and from those multiple individual images calculates maximum and minimum parameters so that all three axes, thickness as well as length and width, are calculated and reported. This further allows the calculation of some additional shape parameters which can't be calculated in traditional 2D image analysis. Microtrac's PartAn 3D products are designed as both online process instruments and lab units for R&D or quality control. The process units, complete with custom designed sampling systems, can be automatically extracting, measuring, and reporting complete size and shape results about every 15 minutes. This provides large processing facilities with near continuous process control response which provides dramatic production cost savings and higher product quality compared to manual sampling and follow-up lab analysis. Here's a random excerpt from an image file of roofing granules. Each row shows different orientations of a single particle. You can see all the different orientations as the particle tumbles through the sensing zone. Note callouts 1, 2, and 3. Callout 1 indicates the view of that particle that showed its maximum length. 2 is the view of the maximum width, and 3 the minimum width, which is assigned to the 3D thickness parameter. All three of the major linear orthogonal dimensions of each particle are measured and reported, along with 39 other morphological parameters. This is the set of parameters Microtrac reports for its PartAn product line. Rather than go into each in any detail here, I'll describe in 4 general terms what they measure. First, of course, is size. We give you 18 different size measurements of each particle in various diameters, length, width, thickness, and more. The last 3 columns are shapes of different natures, and they're generally expressed as ratios of size parameters. Form factors include 13 different parameters that indicate how closely the particle is to being a perfect sphere, or various aspect ratios of the particle. Surface roughness parameters are just that. 3 different parameters can indicate the roughness factor of the particle surface. 2 other parameters report the overall light intensity coming through the particle, transparency, and the curvature of the particle as a gradient of light intensity. Interim size parameters are used to calculate some shapes. But don't be overwhelmed. Only a few parameters are used for any one application. Some of the parameters are available in only the 3D mode, where thickness is used in the calculation. For this application, we'll monitor the sieve parameter size in column 1, a 3D parameter which is calculated from both the width and thickness parameters. And we'll see that it directly overlays the corresponding data determined by a sieve analysis. We'll also monitor transparency to ensure opaqueness, and rectangularity, another 3D form parameter, to check coverage efficiency. Here's a graph of 4 size distributions measured for a shingle granules sample, plotted in cumulative % finer format. Callout 1 points to the actual sieve size distribution, the black dashed curve. Curve 2 is the PartAn 3D measured sieve size parameter, which is seen to overlay the sieve data. Curves 3 and 4 are the measured 3D width and thickness sizes, width being coarser than and thickness finer than the calculated sieve parameter. The PartAn 3D sieve parameter is calculated as a function of the 3D width and thickness, and the PartAn 3D thickness parameter is unique to this industry. The rectangularity parameter is an indicator of coverage efficiency of a granule on a shingle relative to its size. It's calculated as the maximum projected area of a 3D particle divided by the area of the smallest circumscribed rectangle around that particle image. A value of 1 on a scale of 0 to 1 would be a perfect rectangle. Here's another distribution graph with PartAn sieve data size, rectangularity, and transparency all plotted together. The sieve size is the red cum percent finer plot. Rectangularity is the blue differential percent distribution indicating rectangularity at each sieve size, and transparency, the gray differentials plot at each size. Rectangularity on a scale of 0 to 1 is very high, above 0.8 across the distribution, indicating good coverage efficiency. Transparency is low on the scale, indicating pretty opaque particles in all size fractions, but becoming less opaque as they get smaller, which can be expected. Here are two scatter diagrams, the blue area, which are plots showing the location of every particle in a sample relative to any two size or shape parameters, plotted on the top red x-axis and on the right y-axis. On the left, rectangularity is shown relative to width and relative to length on the right side. The shape factors plotted here report the entire shape distribution. But on the XY graph, which was on the previous slide, the shape factors were reported for each individual size fraction. Here, an average rectangularity of 0.8 corresponds to an average width of 1.4 millimeters and a length of 2.6 millimeters. In summary, the size distribution of roof shingle granules must be measured according to the ASTM D451 published size intervals. Image analysis technology is the ideal automated method to replace sieve analysis for measuring these parameters for process control. Microtrac's PartAn 3D image analyzer measures the sizes, opacity, and a parameter which indicates coverage efficiency on the shingles. And with that, Claudia, I'll turn it back over to you for a wrap-up.
Thank you, Terry. Okay, we're going to begin answering any questions that you may have had during today's presentation. As a reminder, you can still submit your questions through the questions pane in your attendee control panel on the right. So our first question that came in is, how does making multiple measurements of one particle allow 3D analysis?
Okay, well, that's a good question, and it was covered somewhat, but I'll compare it to 2D analysis. In 2D image analysis, every photograph, every image taken of particles passing through the sensing zone is taken of only one random orientation of that particle. So unless it's a sphere, it'll have different sizes depending on from where you view it. The 3D analysis, by taking a series of the same particle in all the various orientations, allows you to find the image that has the largest length, the image that has the largest width, and the image that has the smallest width, and assign the length, width, and thickness parameters to those values. And if you need a further explanation of that, let Claudia know, and I can contact you directly to discuss it.
Right, you can just reply to the email that you received for the webinar invitation. Okay, thank you, Terry. Another question that we received was, how long does it take to process the data at the end of an analysis?
As soon as the analysis ends, all of the data, all 42 parameters for every particle are available. The reports are all ready immediately.
Oh, okay. We also received a question. What is the actual ASTM standard? I am not seeing 451 by itself.
It exists as a standard by itself, ASTM D451. You can look it up on the ASTM website, and I can go back to a slide I showed here. This is just an excerpt here from ASTM standard D451, which indicates all of the different size intervals that need to be reported for roofing shingle granules.
Okay.
If you give Claudia your email address, I can send you the link to get to the ASTM standard.
All right. Sounds good, Terry. Thank you. Another question was, what specific functions relate to the Crumbian-Schloss diagrams for sphericity and roundness?
Okay, we didn't talk about them, but those two parameters are requirements to be measured for an API standard for proppants used in fracking. Sphericity is a measure of how closely the particle image comes to being a perfect circle. And roundness is a measure of the edge of the particle and how round the curves are. So those two parameters need to be reported for the API standard because the proppants have to be shaped such that gas or petroleum can freely flow through the proppant bed. That's a different application, but that's what those two parameters are.
Okay, and so it looks like there's a concern about D451 addressing or requiring sieve analysis. So, all right, let me just read this exactly as it was written. I believe you addressed this on the slide that's up right now, but this really doesn't meet D451 requirements as image analyzers are not part of the procedure currently for certifying product based on this method. Is there something that is being pursued to be incorporated into the procedure?
We are not pursuing it, but there's an ASTM committee that will most likely be considering it in the near future. And I'm trying to get to this slide now where I talk about so here I say that the final product batch still needs to be certified by sieve analysis before shipment. But size can be quickly controlled during processing as often as every 15 minutes using the image analyzer. So the final product batch still has to be measured on sieves and sent along as a certificate with the shipment. But during the processing, you can maintain tight quality control by measuring the parameters that we talked about today and determining whether your product is in spec.
Okay, great. Thank you, Terry. Another question is, have you done any studies relating the PartAn 3D to a sieve analysis?
We do that all the time, and we have a lot of applications where people are using the PartAn in place of sieves. This is the slide where I showed the actual sieve data per the ASTM size intervals, and that is the black dashed curve here, call out 1. The parameter that the PartAn calculated is the sieve parameter, and that is the red curve that is directly overlying the sieve analysis. There are many customers in the field that are using the PartAn 3D sieve data in place of sieve analysis. It's more accurate and reproducible, it's less costly, and it's less time consuming.
Okay, Terry, how about for the lab scale instrument, what is the recommended sample size for roofing granules?
That's generally up to the customer, and they determine that by testing different sample sizes. And the way you can do that on the PartAn is by watching the histogram of the size distribution changing as you first start measuring a sample. As soon as that distribution stops changing, it means you've measured enough sample that it was a representative sample of your stream. And then you can use that sample size in all your subsequent analyses. It'll differ for different applications and different size ranges. Usually it would never take more than 5 minutes. And in 5 minutes, you can get hundreds of thousands of particles measured, sometimes up to 1 million.
All right, it looks like, oh, we have another question. Okay, for the online model, what size range is covered by this instrument?
35 microns to 35 millimeters.
Wonderful. Okay, so it looks like oh no, here's another one. Have you seen a difference between samples that have been split versus unsplit using a sample splitter?
Well, the general answer to that question is whenever you can, always use a splitter. Grab samples are notorious for giving unrepresentative samples. So use a splitter whenever you can. There are many types of splitters. It's the only sure way to know that you're going to be measuring a representative sample. And I can tell you that a rotary splitter is the best splitter to use. And you can find those on various websites like Gilson and other suppliers of equipment for splitting samples.
All right, thank you for attending and have a great day.